Hi, my name is Aileen Martinez. I'm from Colombia. Actually, I'm studying a master's degree in materials engineering. My research project is about conditions for chemical activation of cocoa waste derived carbons to be used as electrodes in supercapacitors. Cocoa production waste can be repurposed to create high-value products within a circular economy. One promising application is developing activated carbon for energy storage devices like supercapacitor electrodes. Research are exploring methods to produce activated carbon from biomass with storage capacity influenced by biomass type, activation method, and carbonization. This study used chemical activation with zinc chloride as the activated agent and cocoa industry waste as the raw material. So the process consists of the cocoa was dried at 80 degrees Celsius to get rid of the moisture and alcohol content in the material. The cocoa was pre-treated with hydrochloric acid 1 molar, followed by washing with distilled water until the washing water obtained a pH close to neutral. Finally, these pre-treated waste were dried at 80 degrees Celsius to eliminate moisture and prevent decomposition. Pretreated waste was impregnated with the activated agent zinc chloride in different weight ranges of activated agent waste 1 to 1, 2 to 1, and 3 to 1. The impregnation was carried out by magnetic stirring. The waste impregnated with the activated agent was carbonized in a tubular oven to temperatures 650 and 900 degrees Celsius, where selected based of thermogravimetric analysis results conduct of the impregnated samples. The process was tested with two heating duration, 30 minutes and 120 minutes, and at heat rate of 10 degrees Celsius per minute, and nitrogen flow rate of 100 cm cubed per minute to prevent the combustion of organic material. Then, the thermally activated sample was impregnated with 1 molar of hydrochloric acid solution for 30 minutes to remove the excess activated agent. It was then washed with distilled water to neutralize the pH, and it was dried to obtain the final sample. Finally, the electrochemical properties of these carbons were examined using cyclovoltamperometry and galvanostatic charge and discharge methods. About the results, in Figure 1a, a thermogravimetric analysis was conducted on cocoa house waste before and after washing with hydrochloric acid, revealing that this washing process lowered the ash content in the sample. This is significant because high ash content can reduce the material's storage capacity. Based on the thermogravimetry analysis of cocoa house waste treated with zinc chloride in Figure 1b, temperature of 650 and 900 degrees Celsius were chosen for the thermal activation of the materials, as the weight percentage remained stable within this temperature range. After producing the activated carbon, cycle voltamperometry was performed to assess their capacitance values. The ACA2 900 to 120 and ACA3 900 to 30 carbons demonstrated the highest capacitance measuring 77 and 75 farads per gram, respectively. In Figure 2 displays the voltamperograms of these carbons at varying scaling rates, with the ACA3 carbon exhibiting greater stability as the scan rate increased. According to the results in Table 2 and 3, the ash content of this carbon after washing with hydrochloric acid was 0.46% for AC2 and 0.47% for AC3, with fixed carbon content at 65% for AC2 and approximately 74% for AC3. In terms of surface area, AC2 had a surface area of 1,266 square meters per gram, while AC3 had a 1,400 83 square per gram. To explore the difference in electrochemical performance between these carbons, galvanostatic charge and the charge test were conducted. Figure 3 illustrates that Ac3 carbon retains capacitance more effectively as the current density increases, compared to Ac2 carbon, indicating superior electrochemical performance in Ac3. This advantage may be due to the greater surface area, higher mass support volume, and higher fixed carbon content of Ac3 carbon. Conclusion: it was found that ACA3 900-30 carbon is well suited for use as an electrode in supercapacitors with a fixed carbon content of 74%. This material showed a capacitance of 75 farads per grain and 5 millivolts per second in cycle bond amperometry, and a higher capacitance of 67 farads per grain at a current density of 0.5 amperes per grain in galvanostatic charge and discharge compared to ACA2 900 to 120. Furthermore, ACA3 900 to 30 retained its capacitance values at various current densities, indicating its viability as an electrode for supercapacitors.